Alright, hi everybody. This is going to be the test 3 video key, and I'm going to get started. So number 1, it says the Pell numbers can be defined recursively, and it gives this recursive formula here, and it's asking for the value of P6. So here is our formula. So it says 2 times the previous term plus the term before that. So P1, it gives us, is equal to 0, and it gives us P2, or P of 2, which is 1. Then to do P of 3, I'm going to need to apply the rule. So it's going to be equal to 2 times the last term, which is 1. So 2 times the previous term, plus the term before that. So plus, in this case, the term before 1 was 0. So this will be equal to 2 times 1, which is 2, plus 0, still 2. Now P of 4. So that'll be, again, 2 times the last term, which is 2 now, plus the term before that, which is 1. 2 times 2 is 4, plus 1 is 5. P5 is now going to be equal to 2 times the previous term, which is now 5, plus the one before that, which is 2. So 2 times 5 is 10, plus 2 is 12. Now we've got P of 6 finally, and it will be 2 times the previous term, which is 12, plus the one before that, which is 5. 2 times 12 is 24, plus 5 equals 29. P of 6 is equal to 29. All right, on to the next slide. Number 2. The table below shows the results of a survey in which workers between the ages of 26 and 45 were asked to have, if they have at least 1 month's income set aside for emergencies. So here we have it. If 2 different workers are randomly selected, find the probability that they both have 1 month's income or more set aside for emergencies. So we're just talking about 2 different workers. It doesn't talk anything about gender here. So I think I'm just going to ignore gender. And what is the probability that they both have 1 month's income or more set aside for emergencies? Okay. So 1 month's or more means it's these folks are going to be my numerator. These are the people who have set aside 1 month's or more salary. And then the other question is how many total people there are, right? Because it's always part over whole. So I'm going to calculate the whole population first. So I need to add together all of the men and all of the women. It doesn't look like anyone's getting double counted here, so I can add all the numbers together. So 66 plus 83 plus 76 plus 62. And we have 287 total people. And then of the people who have 1 month's income or more, that would be 76 people plus another 62 people. So that would be 138. So it should be, I believe, 138 out of 287 people have set aside at least 1 month's income. And as a percentage, let's see what that is. That would be 138 divided by 287. So about 48%. That would be for, oh, but now I have to be really careful. So this 48% represents the probability that one person has that set aside. So to find 2 people, 2 different people, I need to take the probability that one person has it set aside. So I'll say 0.48, and I need to multiply that because I need to find one person and another person by 0.48. So when I take that and I multiply it by itself, I get 0.23. So there we have it. This is going to be the probability that they both have 1 month's income or more set aside for emergencies. So 0.48 times 0.48 equals about 0.23. I don't know why it's not letting me write that. Whatever. It's circled. Onwards. Number 3, a controlled experiment would be which of the following most appropriate for which of the following studies? Lunch preferences, determining if a calculator improves test grades, determining the personality factors that help children develop friendships, determining which sports team is the favorite of the female students. Okay, so 4 seems like something I would survey for sure. I would also probably survey for lunch preferences, right? I'd probably just ask. Determining factors that, yeah, I might survey that as well. I would do an experiment on number 2 to see if a calculator improves test grades, right? Some people would get a calculator, some people would not get a calculator, and we would compare them. That would be an experiment, which is equivalent to this. So taking a look here, I'm trying to see what they did. All right, it looks like they treated this less as an exponent and more as a radical. So I think I will do it that way. All right, so we've got a cube root going on, and it's 8x to the 4th times y to the 6th. So that's the same thing as the cube root of 8 times the cube root of x to the 4th times the cube root of y to the 6th. The cube root of 8 is just going to be 2, because 2 times 2 times 2 is 8. The cube root of 8 is 2. This guy right here, I can pull out one group of 3, so I'll have one x on the outside, and under the radical, I'm going to have one x left, right? Because if I were to actually write this out, right, it's like I've got a cube root, there are 4 x's. I'm pulling out one group of x's, those are going to the outside, and there's one x trapped underneath. Then for the y's, I can pull out two groups of y's, because I've got 6 of them. So I can find a group of 3 here and a group of 3 here. So I'm going to have a y squared on the outside, and there will be no y's left on the inside because I was able to take them all out. So let me see if that is an option. I've got 2xy squared. Yeah, and of course this is a cube root here. The cube root of x is all that is trapped inside of this radical. For number 5, it's asking me to solve this equation here. So immediately I'm going to be wary. There might be some extraneous solutions. I, for instance, know I probably can't have a negative under this radical, so something like -7 I think is already out, right? Because -7 minus 1 would be -8, and you can't take the square root of a negative number. It's just not going to work very well. Everything else looks okay. I could just go ahead and start plugging these answers in, but just for practice, I'm going to solve the equation. So I've got the square root of x minus 1 is equal to x minus 7. Square both sides. This becomes x minus 1, because this cancels with that, equals, when I square this, I'm going to get x squared minus 14x plus 49. Add 1 to both sides, subtract x from both sides, and I get 0 equals x squared minus 15x plus 50. Alright, so 10 and 5 would add to -5 and multiply to 50. So I'm going to factor this as x minus 10 and x minus 5, which means my two solutions will be x equals 10 and x equals 5. So that means this 5 radical 2 guy's out. Now I need to make sure that neither of them is extraneous. So if I plug in 10, I'm going to do the square root of 10 minus 1, so that would be the square root of 9, which is 3. Equals 10 minus 7, which is 3. So 10 definitely works. 5, when I do 5 minus 1 and I take the square root, I get 2. When I do 5 minus 7, I get -2. So this is extraneous, and my only solution is going to be 10. Answer choice number 4. For number 6, it says Sabrina is playing with her dog, and there's this parabolic path. Okay, the ball is traveling in a parabola shape. Her brother Bobby is playing in a tree next to her. He shines his laser pointer from the tree in a line that can be modeled by this function. At what points will the ball and the laser beam intersect? So I just want to know when this equation here and this equation here are going to intersect. I want to know when they're going to be equal to each other. So I'm just going to solve it by graphing. So in my y1, I'll do a fraction. And I am doing -1 over 2 parentheses x minus 3 parentheses squared plus 7. In y2, I'm going to do -1, do a fraction again, half, and then it's going to be x plus 8.5 graph. Alright, so I've got my standard window settings. Here comes the ball, and here is the laser pointer. It's hard to tell how many intersections we have. If I go to second and then trace, and I do the intersect command, I'll try it on the left side, enter, enter, enter. And we get one right here at 3,7. And I just want to make sure that there isn't one at like 4, 6.5 or something. So there's a very real possibility there is. What I'm actually going to do is I'm going to zoom in just on this section of the graph. So if I just select zoom in, let's see what we have. Here's the vertex. Crosses once, it crosses twice. Yeah, there are definitely two solutions. So I'm going to do an intersect command again over here. And there we have them. There are two solutions, 3,7 and 4, 6.5. Answer choice number 3. All right, number 7. It's not letting me advance the slide. Come on. I have to do this by hand. Move this and move it back. Boop. Okay. Determine which of the following has the largest maximum. Great. All right, well, maximum is always going to be a y-coordinate, right? Because like you're going to have parabolas that go up, and they're going to have a maximum. So this first one, I'm going to do number 1 over here. X squared plus y equals 4x minus 8. Well, I've got to subtract x squared from both sides to graph this thing, and I get y equals negative x squared plus 4x minus 8, and I'm just going to graph it. So I'm going to do a zoom standard just to make it normal again, stop that from happening, and graph it. Clear this stuff out. Negative x squared plus 4x minus 8. I'll take a look. Alright, so there's my maximum right here, and I can see that my maximum is like negative something, negative 1, negative 2, negative 3, negative 4 maybe negative 5. I'll say it's about negative 4. I don't even know what it is, but it's definitely not the largest because I can see some of these other maximums. I can eliminate it because I can see this maximum here, 1, 2, 3. This maximum is a positive 4. This maximum here, negative 1, negative 2, is 3. So that's out too because this one's bigger than that. So now I just need to check this other one. And actually I know it's going to be higher because I think that this is going to be shifted up 5 units. So I'm almost positive that this one will in fact have the highest maximum, but let's just double check. Negative parentheses x minus 3. So that x minus 3 is going to move it to the right 3 squared plus 5. Right 3 up 5. And yeah, sure enough, I can just do a maximum command. Second trace, maximum, left bound, enter. Move over to the right side for the right bound. I'll do something somewhat symmetrically there. Right bound. Guess. It says that the maximum, the y-coordinate, is about 5. So this one is indeed shifted up 5 units, and it has the largest maximum. All right, number 8. I don't know why I keep having to move the screen, but I guess I'll keep doing that. Professor Mogg has 184 students in her math class. The scores on the final exam are normally distributed and have a mean of 72 and a standard deviation of 9. What percentage of students in the class can be expected to receive a score between this and this? Okay, cool. So this is a normal CDF question for sure. Oops, I don't know why I did that. So I go second vars to the distribution page there, and I'm going to do normal CDF. Okay, so let's see. There's a mean of 72. I'm not going to worry about my upper bound yet. I'll come back and put that in. A standard deviation of 9. And I want to know scores between 81, so that's my lower bound, and 90. It just says what percentage. So the fact that they told me how many students there are doesn't actually make a difference here. And when I run this thing, I get 13.5%. And I'm just going to take some screenshots here for you guys. Again, I did second vars, normal CDF, and this is what I put in. So I got 13.59, so that rounds up to 13.6% of the students are going to be in that interval. All right, on to the next one, number 9. So here it says if sine of theta is equal to this, where theta is an angle in standard position that terminates in quadrant 2, what's the value of tangent of theta? So I'm just imagining, I know that sine of theta equals SOH. Sine is opposite over hypotenuse. I know I'm in quadrant 2. There's my right triangle. So sine is equal to opposite, so this is going to be 7. And hypotenuse is going to be 25. All right, I know immediately tangent is going to be negative in this quadrant, so this is out, and this is out. All right, that's tangent is negative in quadrant 2. Tangent's only positive in 1 and 3. All right, so then I just could do Pythagorean theorem. I can say 7 squared plus b squared equals 25 squared. 7 squared is 49 plus b squared equals 25 squared. I'm going to pull up my calculator. 25. Oh my goodness, I can't get out of this. 25 squared. 625. I'm going to subtract 49 from both sides. 576, and then you take the square root, and you get 24. Wow. All right. So b equals 24. So then tangent is always opposite over adjacent, and really this is like a negative 24 because I'm moving that way. So opposite side is going to be, so I can say tan of theta equals my opposite side, which is 7, over my adjacent side, which is negative 24. And I get answer choice number 2. All right, how many complex roots does this have? Okay, so let's think about this. These roots here are going to be real. It'll be equal to 0 at some point. This here, there's going to be a real root too. So, I mean, we have a real root at, what would this be? If I solve this equation, I would get add 5, then take square root. So I'd get radical 5 and negative radical 5. If I solve this equation, I'd be subtracting 6 and divided by 2. So I get negative 3, right? X equals negative 3. X equals that and that. These are also real. But then this thing here, x squared plus 4 is going to give me complex roots, and x squared plus 10 is going to give me complex roots because, well, when I actually solve both of these equations, I'm going to have negatives under radicals, right? So if I were to solve this, if I were to set it equal to 0 and solve, if I set this equal to 0 to solve, I'd get x squared equals negative 4, and then I'd have to take the square root of both sides, and I get x equals 2i. Here, I would subtract 10, and I'd get x squared equals negative 10. I'd take the square root, and I'd get x equals I radical 10. And anytime you do a square root, you're actually getting a positive solution and a negative solution. So we'll wind up having 2 complex roots here and 2 complex roots here, which means that in total, I believe we are going to have, yes, we will certainly have 4 complex roots, positive and negative 2i, and positive and negative I radical 10. All right, here we have a system of equations, 3 by 3. So again, I'm going to open up my calculator and I'm going to do it on there. So if I open up stat, and not stat, I'm going to go to my matrices. So a matrix second, and then the matrix button. And I'm going to edit a matrix. The matrix is 3 tall, and it is 1, 2, 3, 4 long. So it's a 3 by 4 matrix. And I'm going to put in my values. I've got a 1x, a 2x, and a 1x. Just going down the equation here, right? Now I'm going to do a 2y, a y, and a 2y. 2y, a 1y, and a 2y. Now I'm going to do my z's. I have a negative 1z. Then I have a 1z and another 1z. Then over in the last row I have a 3, a 0, and a 5. Alright. Then I'm going to quit to my main screen. I am going to do math, or second matrix again, rather. Sorry. I'm going to do an rref. I'm going to math rref. and then again, second matrix of matrix A. That's my matrix that I want to do. And I'm going to hit enter, and I get this. So I know that this means, right, the one in the first value here was my x variable. So x equals -2. The second variable, y, is going to equal 3. So I can say y equals 3 and z equals 1. These are my answers. So that looks like answer choice x equals 2. Answer choice number 3. All right, 12. This is some function. It models the population of a city in hundreds 2 years after 2010. How many people lived in the city in 2010? And at what rate is the population changing? So it says that it's modeling the population in hundreds. So this is where I'm starting. So I am starting at 43,000, but this represents the number of hundreds we have. So if we have 43,000 hundreds, I need to take 43,000 and multiply it by 100. It's going to add 2 zeros to it, right? And we wind up getting this many people. So if I put my commas, I have, let's see, 4.3 million people. All right, next up, is it increasing or decreasing by by 0.25%? Interesting. Well, my inclination would be that you've got this negative sign. But honestly, I think I should graph it. It's embarrassing, but I'm going to graph it. I should know that off the top of my head. I'm sure I could reason it out, but we're just going to see what it looks like. All right, negative. All right, and now I'm going to adjust my window settings. I'll set my x max to 0 because at the time we can look at it for 10 years. That's fine. My y min, 0 people. My y max, I'll say 50,000, and we'll graph it. Yeah, and sure enough, this thing is decreasing. So there's a graph of my function. It is decreasing by 2.5% each year. All right, if two things are independent events, which the following is not necessarily true. So independence means that the probability of A given B is equal to the probability of B. That's one definition of independence. Another one is the probability of A times the probability of B is equal to the probability of A and B. So those are two definitions I'm going to work with right now. So, okay, here's the first one. So that is true. Probability of A and B is equal to the probability of A. Then, or given, I should say. And then here's the other one. So now I'll think about it for a second. Let's take a look at this one. Okay, the probability of B given A is the same as the probability of A. So the probability, this is basically just saying that the probability of B if A happens is the same thing as A happening. This is saying the probability of B is the same as the probability of A. So I don't think that's necessarily true. I'm pretty sure that's right, but let's make sure this one works. This says the probability of B given A divided by the probability of B equals 1. Yeah, so that's another way we could write this, right? Because if I had the probability of B given A is equal to the probability of B, this would be independent events. And then I could just divide both sides by the probability of B. Those would cancel. Anything divided by itself gives us 1, and so you get this equals 1. So that is also true, and yes, 4 is the one that doesn't make sense. That is not necessarily true. All right, 14. All right, I'm going to solve this thing. So x squared, I'm going to go ahead and add 7x to both sides, plus 7x minus 12 equals 0. And it looks like there's a pretty decent chance I'm going to need the quadratic formula. Can I think of two numbers that add to 7 and multiply? 12 and 2, 6. Or 6 and 2, no. 12 and 1, no. 4 and 3, yes. No, actually this will work. So I can do x, hold on though, adding to 7, multiplying to -12. You know what, I'm going to use a quadratic formula. I might just be psyching myself out and you might be like yelling at this video right now. I'm going to do the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. Alright, let my calculator do the thinking for me. 7 squared minus 4 times my a term, which is 1, times my c term, which is -12, and I get 97. So -7 plus or minus square root of 97 over 2. So that would be 7 plus radical 97 over 2, and -7 minus radical, whatever that is. So it is going to be answer choice number 2. Alright, 15 says a rabbit farm currently has 25 rabbits, and the population is doubling every 3 months with this equation here, where t is the number of years since the population was 25 rabbits. So it's starting at 25, it's doubling. If the farm does not sell any of their rabbits, after how many months to the nearest whole number will there be 3,000 rabbits on the farm? So I want to know when r of t, the number of rabbits, is equal to 3,000. So I'm going to set up an equation. So I'm going to say that r of t is going to be 3,000 equals 25 times 2 to the 4t. So to solve this, I'm going to divide both sides by 25. 3,000 divided by 25, let's see, goes in 120 times. Alright, so now I'm going to log both sides and kick this thing to the front. So I get log of 120 equals 4t log of 2. I'm going to divide both sides by 4 log of 2. And that cancels the 4 and the log of 2, and I'm going to get t is equal to, well, let's see. So I'm going to do log of 120 divided by 4 log 2. And I get t is years. So we want months. So I know it's going to be 1.7 whatever years, so 1.73 years. I'm going to multiply that by 12 to get months. So about 21 months. So that would be about 21 months. Whew. Alright, number 16. Let me just actually double check that. 15 is 2. Yes, good. Okay. 16. Which type of regression will model the situation? That's all I need to know. Alright, so it's going, it's really dropping quickly. I'm going to graph it. Honestly, I think that's probably the best way to go. So I'm going to go to stat, I'm going to go to edit. I've got 0, 5,700, 11,400, 17,100, 22,800, 28,500, 34,200, 39,900, 10,000. 156 and 78. Okay, so now that they're all in there, what I'm going to do is I'm going to clear this guy out. I'm going to turn my plot on just to see what these points look like. And I'm going to hit graph. And of course I can't see anything, so I can do zoom stat, this 9th option, zoom stat, right here. And let's see. It looks like this. So it's looking, well, it's definitely not linear, it's definitely not trigonometric, which means it's either logarithmic or exponential. And it looks to me like it is exponential decay. So I'm going to go with exponential decay. There we have it. All right, this is my second time doing question 17. I actually made an error the first time and just caught it, so I'm going to do it again. All right, so here it says you select a person at random from a large group at a conference, just one person. What's the probability that the person selected has a birthday that is not in August? So my first thought was, well, if it's not in August, it could be any of the other 11 out of 12 months. But then I realized that not all of the months have the same number of days, so I have to do this by days. So I know in a year there are 365 total days, and then I need to know how many days are in August. So I use a poem, 30 days, have September, April, June, and November. Okay, that means August has to have 31. So August has 31 days. One moment here, one second. All right, so August has 31 days in it, which means that the rest of the year contains, let's see, I'll do some subtraction here. So I'm going to do 365 days in the year minus the 31 days in August, and you get 334 days. So we wind up with 334 of the 365 days in the year are not in August. That is option 3, right? 365 minus the 31 days is 334. Now the work is on the page. All right, 18 I'm supposed to divide. All right, x goes into x squared, x times, distribute. X squared minus 7x. Subtract. Those cancel. Negative 3 minus negative 7. So that's negative 3 plus 7, that is 4x. X goes into 4x 4 times. Bring down 28 here. I should have done that already. That comes down. X times 4 is 4x. Negative 7 times 4 is negative 28. All right, 7 times, yeah. Yes, cool. Then you subtract again. Those cancel, and those cancel, remainder 0. So when you divide this by x minus 7, you get x plus 4. Goes in evenly. I guess I could have just factored that, huh? All right. So 2 methods of instruction are used to teach athletes how to shoot a basketball. There's group A getting one method, group B getting another method. The students in each group took 30 foul shots after each of 10 sessions. The average number of shots made in each group, in each of the rounds, X rounds, by athlete using method A can be this function here, and then athlete B is this function. In which of the 10 rounds will the number of baskets made with each method be the closest? Okay, so I'm going to graph them both so I can make a good comparison. So I should actually move my calculator here. Let's see if I can manage to do that. I think I actually just might open a new one. It's kind of oddly in the way. All right, so there's my calculator. I go into here and I'm going to graph them. So the method A is 11.9 plus 4.3 ln of x. Method B is 9.17 times 1.109 to the x. And now I'm going to compare. So this is what we've got. These comparisons don't seem fun. I really don't want to do subtraction. I'm going to have to subtract, aren't I? Okay, so I will just compare each. So the options are 6, 7, 8, or 9. So let's just take a look at all of them. So in 6, I just need to take the difference between the two. right? So actually, here's what I'm going to do. I feel lazy, so I'll teach you guys a trick. I want to know the difference between y1 and y2, so what I can do is I can actually go into where it says variables, go to my y variables, and I can say y1 minus vars, y vars, function, y2. So this will calculate the difference between y1 and y2. So let me just drag that in over here. So I've got y1 minus y2. And then I'm going to go into my table and we'll see when they're closest. So if I go over here to y3, it will tell me when they are closest together. And it looks like after 8 weeks, they're only 0.13 apart. So something like that. I'm going to drag that in here. So after 8 weeks, they will be very, very close together. 19 is, all right, for 20 it says the graph of a quadratic function f of x is shown to the right. What is the remainder when f of x is divided by x minus 2? So to do this, I'm going to use remainder theorem. So remainder theorem states that f of a is equal to, well, x minus a. So I said that wrong. So let me just double check exactly how it phrases it on the internet. I'm going to pull it up. I just did some Googling just to make sure I was good. It says that the remainder of the division of a polynomial f of x by a linear polynomial x minus a is equal to f of a. Yeah, so the remainder, I should say, is going to be equal to x minus a. So that means I can do f of 2 to find the remainder when I divide by x minus 2. If I'd been dividing by x minus 3, I would have done f of 3. Anyways, f of 2, so if I go to f of 2, that would be equal to negative 1, negative 2, negative 3, negative 4. It's right here at around negative 5, so that would be right here, answer choice number 1. It's about negative 5. I think the graph's actually a little off. I don't love that. Okay, so now it says to write this in standard a plus bi form. I'm just going to let my calculator do the work on this one. So I'm going to go into my calculator. Just to be safe, I'm going to use ipart. And I am going to do another set of parentheses. 2 plus I to the third power gives me 2 plus 11i. So 21 is 1. Good. All right. Monthly compounding. So we've got a first amount. Okay, so this is continuous compounding because it's got the e. It's compounded monthly, so I should have 0.03 divided by 12. It's got to be this one here. Starting with $6,000, you take the previous amount, you multiply it by the monthly interest rate, and we are good. Yeah, so 22 should be 1. All right, find the inverse. So I'm going to say switch x and y. So x equals negative 2y plus 5, subtract 5, get y by itself. So I get y equals this, which isn't an option, so I could divide both of them by negative 2, and I get x over negative 2 minus, or really, a negative divided by negative is a plus 5 over 2. It's supposed to be a 2. Just can't speak and talk and write at the same time. Okay, so that would be answer choice number 1. X divided by negative 2 over 5 halves, or plus 5 halves. Good. All right, 24. Let the table below lists Americans who are expected to be over 100 for the selected years. Let X represent the number of years after 2010. So that means this is going to be X equals 4. This will be X equals 6. This is 8 years after 2010, 10 years after 2010, 12 years, and 14 years. Use a quadratic regression to predict the number of Americans who will be over 100 years old in the year 2026. So this would be when X equals 26, or X equals 16, excuse me. All right, so I'm going to go to my calculator, and I'm going to put in the information. So I've got 4 years after. All right, I'm using the X values based on how many years it's been since 2010. 8, 10, 12, 14. 50, 56, 65, 75, 94, and 110. I'm going to go to stat, I'm going to go to calc, and I'm going to do a quadratic regression because that's what it tells me to do. And here we are. So I want to make a prediction. And what I'm actually going to do here, because I don't want to type all that into my screen here, I'm going to do another quadratic regression, and I am going to store this regression equation into y1. So I'm going to go to second, or not second, just variables, this vars button. I'm going to go to yvars, I'm going to do function, and I'm going to do y1. So I'm taking this regression, and I'm storing it in y1. All right, so now if I go to y1, you'll see they put it in there already for me, and I can check my table. So in 2026, so when x equals 16, this is the point I care about. This is my point of interest. So when x equals 16, y equals 132.4. So 132.4 thousand, I believe, because it says this is the number in thousands. Yep, 132,000. All right, 25. On to the free response section now, guys. 3 years after leaving her best friend's house, Jessica was 400 miles from home. 5 hours after she left, she was 280 miles from home. Write a function where x represents the number of hours spent driving and d of x represents distance. So I'll say d of x equals. And I've got 2 points of interest, right? I know that after, I like to do time, but time is an x coordinate, right? X is hours. So my first x coordinate is 3 hours, and 400 miles is my y coordinate. Then my other point of interest is, let's see, 5 hours and 280 miles. So she's getting closer to home. I'm going to do a linear regression on those 2 points because I don't feel like doing slope formula. I'm kind of feeling lazy right now. Slope formula honestly might be faster, but this will give us everything. So 3 and 5 are my 2 times of interest. 400 is my first distance. 280 is the second distance. Stat, calc, linear regression. And there's my linear regression equation for those 2 points. So I get negative 60x plus 580. So she's going 60 miles an hour, getting closer to home, so the distance is decreasing, and she must have started 580 miles away. All right, now it's asking me to express a of x divided by b of x in this form with a remainder. All right, so let's see. A of x divided by b of x. Okay, I've got to do division. So I've got negative 8x to the 4th minus 10x to the 3rd plus 17x squared minus 4 divided by 4x squared minus 5x plus 2. Just going to make sure I have a 2, a 1, a 0. Good. 4, 3, 2. I'm missing an x term here. So I'm going to rewrite this as plus 0x minus 4. Now I have everything I need. All right, 4x squared goes into 8x to the 4th. What? Negative 2x squared times. So negative 2x squared. So 4 times negative 2 is negative 8. X squared times x squared is x to the 4th. So that's good. Then I keep distributing. This times that. Negative 2 times negative 5 is a positive 10. X times x squared is x to the 3rd. This times that would give me a negative 4x squared. Now I subtract. Those cancel. Negative 10 minus 10 is negative 20x to the 3rd. 17 minus negative 4 is like 17 plus 4, which is a positive 21x squared. Double checking my math there. I think I'm good. Okay. And I'm going to bring down the 0x. All right. Here we go. Now I need to see how many times 4x squared goes into negative 20x to the 3rd. So that would be a negative 5x. So now I'll double check that. Negative 5x times 4x squared. So negative 5 times 4 is negative 20. X times x squared is x to the third. Plus, or maybe it'll be a minus, I shouldn't assume. Negative 5 times negative 5 is a positive 25. X times x is x squared. Negative 5 times 2 is negative 10x. Subtract. Those cancel. 21 minus 25 is negative 4x squared. 0 minus negative 10 is a positive 10. X, bring down the negative 4. All right, and one last time here. So 4 goes into negative 4, negative 1 times, and now I distribute. Negative 1 times negative 4 is negative 4x squared. Negative 1 times negative 5 is a positive 5x. Negative 1 times negative 2 is negative 2 minus 2. All right, those cancel. 10 minus 5 is 5x. And negative 4 minus negative 2 is like negative 4 plus 2, which is a negative 2. So that is going to be my remainder. So I get negative 2x squared minus 5x minus 1 plus 5x minus 2 over 4x squared minus 5x plus 2. And that should be my final answer. I'm now going to check that because I don't trust it at all. Let's see, I'm going to go to the answer key because I have one of those. Not there, but here. Negative 2x squared minus 5x plus 1 plus 5x minus 2 over, yes, I got it on the first try. Go me. All right, onward. Number 27. Determine all the factors if one of them is this. Okay, I'm trying to see if I have a GCF situation and I can actually just do AC method on this. I don't think I can. Okay. All right, so again, I'm going to have to do polynomial long division. That's really the theme of this so far. 3x to the third plus 7x squared minus 18x plus 8. So I have 3, 2, 1, 0, good, okay. And x minus 1 goes in evenly. So we'll do the division. So x times what gives me 3x squared? Well, it'll be x times 3x squared gives me 3x to the third, excuse me. So then I distribute that times that gives me 3x to the third. That times negative 1 gives me negative 3x squared. Subtract. Those cancel. That minus that is 10x squared. Bring down the negative 18. X. All right, x times a positive 10x gives me 10x squared. Distribute 10 times negative 1 is a negative 10x. Subtract. Those cancel. Negative 18 minus negative 10 is like negative 18 plus 10, which is negative 8x. Bring down the positive 8. Okay, x goes into negative 8x negative 8 times. So negative 8x, distribute, plus 8. And hey, sure enough, everything cancels out. You're left with no remainder. So we wind up with x minus 1 times 3x squared plus 10x minus 8, which I can now factor with AC method. So right now, I think I'm actually going to have to change my settings here so my page can zoom out. So let's see. How do I do this? Extend page. I'm going to turn that on. All right. So this thing, I need to find two numbers that add to 10, and then I'm going to do a times c is negative 24. So two numbers that add to 10 and multiply to 24, 12, and 2 will work. So positive 12, negative 2. So this is going to, this is just going to come down. I'll keep track of that. But I'm going to wind up with 3x squared plus 12x minus 2x minus 8. Split that down the middle and factor. So I can factor out a 3x, and I'm left with x plus 4. Negative 2 comes out of this, and I'm left with x plus 4. So I can factor this as 3x minus 2, parentheses, x plus 4, and then this x minus 1 comes down as well, and those are my factors. I can't go any further with this. double checking my work. 3x plus 2x plus 4, great, done. All right, 28. Solve the following equation. Express your answer in simplest a plus bi form. All right. Imaginary numbers are going to happen, so I'm going to use quadratic formula. So opposite of b plus or minus the square root of b squared minus 4 times my a term, which is 4, times my c term, which is 7, all over 2 times my a term, which again is 4. My calculator do the work here for a second. So 8 squared minus 4 times 4 times my c term, which is 7. So I get negative 8 plus or minus the square root of negative 48 over 8. 2 times 4 is 8. Good. Okay. So now I need to find the biggest perfect square that goes into 48. I think it'll be 16. Yeah. Okay. So I can rewrite this as negative 8 plus or minus, well, the square root of negative 1 is going to be an I. The square root of negative 48 can break down into the square root of 3 and the square root of 16. All of that will be over 8. The square root of 16, that becomes a 4, because the square root of 16 is 4. So I can rewrite this again as negative 8 plus or minus 4i radical 3. All this again is over 8. And then I can do some division, because everything here is divisible by 4. So I can divide this by 4, and this will become a 2. I can divide this by 4, and it just goes away and becomes a 1. I can divide this by 4, and it becomes a 2. So I'm going to get negative 2 plus or minus I radical 3 over 2. Now again, I'm going to go to the answer key and check that. Did I do something wrong? Oh gosh, I was dividing everything by 8. Yeah, this I can keep going. Of course I can keep going. Negative 2 divided by negative 2 is a negative 1. My goodness. Could have divided everything by 8. Hold on. Now I got to... Yeah, so the answer I have here would be totally fine. I just cut away and cut back just to make sure I wasn't doing anything wrong, which I wasn't. So what I'm going to say here, actually, I'm going to adjust this. You could equally say negative 2 divided by negative 2 is a negative 1 plus or minus I radical 3 over 2. That also works, right? Or that. Either one is a fine answer. All right, 29. So we've got the height of a saddle of a horse above the base of a carousel. I guess the horse is moving up and down. Can be modeled by this sine equation here, where t represents seconds after the ride started. How much time does it take for the horse to complete one cycle of motion? So this is a period equals 2 pi over b. The b term, well, this is a. B appears to be, the b is always this term here. So that is b. So I can say period equals 2 pi divided by 3 pi over 8, which I will then write as 2 pi over 1 times the reciprocal of this, which would be 8 over 3 pi. That cancels with that. Let's see. 2 times 8 equals 2 times 8 is 16 over 3. And so that would be, making sure I did the math right there. Yeah, I think I did. Okay, so that's t, so that's seconds. That's how long it takes to do one full cycle. All right, it says what is the maximum and minimum height of the horse's saddle above the ground? So to find the maximum, right, basically my function is going to have this midline, and it's going to be going above the midline and then below the midline. And that would happen over the course of one period. So the midline is right here at 42. And then the amplitude determines how high it's going and how low it's going. The amplitude is 12. So it's going to go 12 above the midline here. It's going to go 12 below the midline. So 42 plus 12 is 54. 42 minus 12 is 30. So the minimum equals 30, and the maximum equals 54. All right, moving along, I'm simplifying. So, you know, I could probably I-part this entire thing and it would probably work. So I might do that to check myself. For now, I'm just going to distribute. So I'm going to distribute that. So I get 4i minus 2i squared minus, and then I can FOIL all this out. So I will FOIL all this out. 3 times 4 is 12. 3 times negative 6 is negative 18i. 2 times 4 is positive 8i. And then 2 times negative 6 is negative 12i squared. Then every time I have an I squared, that is the same thing as a negative 1. Okay, so that means this is going to simplify as 4i. Negative 2 times negative 1 is a plus 2 minus, I've got a 12 here. Negative 18 plus 8 is a negative 10i. Negative 12 times negative 1 is a positive 12. I can distribute this negative sign here now. And I get 4i plus 2 minus 12 plus 10i minus 12. Suppose I could have combined like terms first. Doesn't really matter. Okay. 4i plus 10i is going to be a 14i. And I've got a 2, a negative 12, and a negative 12, so that would be negative 10 minus 2 is minus 22. So I will get negative 22 plus 14i. I'm going to double check that. Negative 22 plus 14i. Hey, it worked out. Okay, cool. Back to that. Nice. You could probably I-part this in your calculator and check yourself as well. I bet it would work. All right, here we have Forrest Gump is running for several hours. The table represents the miles he'd run, and after t hours is the average rate of change constant. So average rate of change is just my slope. So let's see if the slope is constant. So for the first interval, he goes from 10 to 18. So he's going 8 miles. It's an 8. And it has taken him 2 hours because it's going from 2 to 4. The next interval, he's going from 18 to 30, so that is 12 miles. And it takes him from 4 to 7, so that is 3 hours. So yes, 8 divided by 2 gives you 4 miles per hour. 12 divided by 3 also gives you 4 miles per hour. So the answer is yes, he is always going. He is always, man, that's messy. Sorry, guys. Moving, we will say 4 miles per hour. All right, 32. A survey was taken of students' genders and their preference for basketball, soccer, or track. 5 girls preferred track, 4 boys preferred track, 6 boys preferred basketball, 15 girls preferred soccer, 25 students preferred soccer in total. Okay, so complete two-way frequency table. So I have to fill in this table. Got it. So far I know that 6 boys preferred basketball. Let's see if I can fill anything else in. 5 girls preferred track. So 5 females preferred track. Okay. 4 boys preferred track. That means in total 9 students preferred track. 15 girls preferred soccer. That's already there. 25 students preferred soccer, so 25 total students preferred soccer, which means that there must have been 10 boys, because 10 plus 15 gives me 25. If 6 males preferred soccer and 16 total, that means 10 females had to prefer soccer. And then I can do all my totals here. It says 25 students preferred soccer. 50 students participated, so there are 50 total students here, which means that this would have to be a 30. Let's make sure that works. 15 plus 10 is 25, 5 is 30. Good, it all adds up. Okay. What is the probability that a student preferred basketball given that they were a girl? So there are in total 30 women, 30 girls. And of those 30 girls, 10 of them prefer basketball. So that would be a 33.3 repeating percent probability, 10 out of 30. Are being female and preferring soccer independent events? Justify your answer. So I want to know if the probability of A, so I should say the probability of A given B is the same thing as the probability of A. So that means the probability of being, female in soccer. So is the probability of being female given that you prefer soccer the same thing as the probability of being female? So of students who prefer soccer, so that is there are 25 students who prefer soccer, and of those 25, 15 are female. Is that equal to the probability of being female? Well, there are 50 students, and of those 50 students, 30 are female. So let's see. 15 out of 25 is 0.6. And I think 30 out of 50 is 2. Also 0.6. So the answer is yes, they are independent events. Yes, they are independent. And then here's my justification right there. All right. Find the solution algebraically. I've got a lot going on here. Algebraically. And then graphically. Okay, so they don't give me a lot of space to do this algebraically, so I'm going to do it down here. I want to set them equal. So x minus 4, the absolute value of x minus 4 plus 2 equals 1/3 of x plus 2. Subtract 2 from both sides. Those would actually cancel out. So I get the absolute value of x minus 4 equals 1/3 of x. So to get rid of the absolute value sign, I know that this thing in the parentheses, I could say that x minus 4 could be equal to 1/3 of x, or x minus 4 could be equal to negative 1/3 of x. All right, so if I want to solve this equation, I could add 4 to one side, subtract 1/3, so that would give me 2/3. X minus 1/3 would be 2/3 of x. So I get 2/3 of x equals 4. So x equals 4 times 3 divided by 2 is 6. Then over here I add 1/3, so that gives me 4/3 of x equals 4. 4 times 3 is 12 divided by 4, x equals 4 times 12 is 3. X equals 4. Is that right? X times 3. No, x equals 3. Times 3. 4 times 3 is 12. Divided by 4 is 3. Okay. So x equals 6 and x equals 3. Then determine it graphically. Okay. So clear that out. Math, num, absolute value of x minus 4 plus 2. Alpha y equals, enter 1/3 x plus 2. I'm actually just going to graph one at a time. And honestly, I didn't even need to do this because I know the rules for these. So to graph the linear equation, I'm actually going to start at positive 2 because that's my y-intercept. And I'm going to go up 1 over 1, 2, 3 because that's my slope. Rise over run. Rise 1, run 1, 2, 3. Rise 1, run 1, 2, 3. Keep that pattern going. 1, 2. Is that right? I guess so. Feels wrong. Down 1 over 1, 2, 3. Yeah, that's right. Okay. Down 1 over 1, 2. And it's going to look something like this. So I'm going to take a straight line. Do my best to connect everything. Okay. Then this other one is an absolute value graph. I know it's being shifted 4 units to the right and up 2 units. So up over 1, 2, 3, 4, up 2. And then I know it's just going to have a slope of 1 on one side, and I could check my table and do this, and then a slope of negative 1 on the other side because it's an absolute value graph. It's going to be V-shaped. And there we have it. And I can see my solutions are right there and right there. So to determine it graphically, I'll just state them right here. X equals 6 is right there. And here we have x equals 3 right here. All right, explain the relationship between the answers to part A and part B. So the algebraic solutions and the graphical solutions are the same. I don't really know what else it wants me to say. So I'm just going to type that. I think that's probably good enough. All right. Here it says first I want to factor this guy completely. So if I want to factor it completely, I need to find two numbers that add to negative 20 or add to negative 25 and multiply to 144. So let's see, 144, 25. So 12 and 12 are 144. 144 is also going to be divisible by 9. What is it? 144 divided by 9 gives me 16. 16 and 9. Yeah, that works. They both have to be negative. So this is going to become x squared minus 16 and x squared minus 9. Yep, and then these both factor because they're both difference of squares. So this would become x plus 4, x minus 4, x plus 3, x minus 3. That factored. Graph it, labeling all x-intercepts. So I know one x-intercept is going to be at a negative 4. Negative 1, negative 2, negative 3, negative 4. One's going to be at a negative 3. One is going to be at 1, 2, 3. Oh, well, positive 3. 1, 2, 3. And one's going to be at positive 4. So I'm labeling these. So this is, well, let me graph it first. I guess I should probably plug it in. So I've got x to the 4th minus 25x squared plus 144. And let's look at our, oh, before that I'll look at the table. Just make sure that looks right. Yep, sure enough. Okay, something like that. So I'll see if there are any points that I can easily graph. So negative 4, negative 3 are both zeros. Everything else is just, it's pretty wacky. I don't know if I can do this. So it's like it's coming down really, really fast. It's hitting this. It keeps going really, really far. It comes back up. It passes through here. And then it goes, oh, it says choose an appropriate scale. All right, I need a better scale. I can't really see anything here. What are my minimums? All right, I'm gonna just play around with this a little bit. I think the X scale is fine. I think the Y scale should probably be changed. So my Y minimums, I want to say they were pretty close there. So maybe, oh, I don't know. Well, I want it to be symmetrical. So the y-intercept is all the way up here at 144. So I'm going to make my y max like 150. I'm going to make my y min negative 150 just so it's nice and even. And I'm going to count by, well, let's see, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to count by 20s. And then it looks something like this. So if I count by 20s, I can actually graph this just fine. So this would be 20, 40, 60, 80. Right, I'm going to label it 20, that's 20, 40, 60 would be here. This would be 80. This would be, no, I'm not doing that right. Okay. So actually 20, 40, 60, 80, 100 would be right here. 120, 140, 160, yeah, okay. So if I go into my calculator here, I have the point 0, 144, right? So my y-intercept is like right here. Then around that I want to graph the points of interest, right? So -1 is at 120. So So that would be right here. 0, negative 2 is at 60, so 20, 40, 60 would be right here. Negative 1 is at 120. Did I do that already? Yeah, I did that. 60, 0 is at 1. Why is this so hard to do? Negative 3 is 0. Yeah, okay. Negative 4 is 0. And then in between, I'm kind of curious what my roots are. I can figure that out in a bit. And then it's going to do the exact same thing on the other side, I think. So 120, 60, 0, 0, yeah. 20, 60, 0, 0. And then I think it's going to turn around and come back up on the other side. So 144 is at 5, 5, comma. It's right back up to 144, which means it'll be doing that on the other side as well. And I have a graph that looks like this. So I'm actually going to do it in a different color. I'll do it in blue. I like blue. So it's going to come down. It's going to do something like this. It's going to turn around. It's going to come back up. And pass through all these points. It's pretty hard to do this with on the computer. Okay. And there's my graph. Something like that. So I need to label all of these things here. So my independent variables, or my zeros here, are negative 4, comma 0, negative 3, comma 0, 3, 0, and 4, 0. All right, my scale was counting by 20s. I think I indicated that just fine. And the connection between your answers. So I know that the factors, or maybe the, how can I put it? The solutions, or maybe the x-intercepts, I could even say, had opposite sides. So how about the x-intercepts and the factors had opposite signs, right? So we had factors at positive x plus 4, we had an x-intercept at x minus 4, and so on and so forth, like we've learned. Okay, great. So on this one, it graphs this thing, and it's saying graph g of x. So g of x is, well, let's see, there's a transformation happening. So it's going to the right 2, and then it's going down 3. So each point goes right 2, 1, 2, down 1, 2, 3. Right 1, right 2, down 1, 2, 3. Right 2, down 1, 2, 3. Right 1, 2, down 1, 2, 3. Now I'm going to connect it with a line. Make sure that looks right. Okay, cool. Is it even, odd, or neither? So to me, I know it's not even because it's not like symmetrical about the y-axis, but I do think it's odd. And I think it's odd because I think if I rotated this 180 degrees, it would be the exact same. And I think I can actually prove that. So let me try something with the technology here. Let's see if I can do this. If I group this line, I think I can actually rotate it 180 degrees. So let me see. If I rotate this 180, oh no, that didn't work because I grouped the wrong things in there. Undo. Let me get this out of there before I group it. I'm going to try one more time. Remove that, remove that. Yeah, and it's not letting me do it. So I do believe it's odd, and I think it has rotational symmetry, right? Because if I took this point and I rotated it, it would go here. If I took this point and I rotated it, it would go over here. So I will say it is an odd function because it has rotational symmetry. Let's say that, okay. All right, so it is asking me what is the y-intercept, zeros, is increasing over interval, relative extreme. Okay, let's graph this thing. So, well, some of them I can do pretty easily. I know the zeros, I just have to flip these signs, right? So the zeros are x equals negative 2, x equals 1, and x equals 5. I know the y-intercept is the y-coordinate when x equals 0. So if I want to find the y-intercept, I just have to plug in 0 for x here. So this would become a 2. This would become 0 minus 1 is -1. 0 minus 5 is -5. Multiply all this together. -1 times -5 is +5. So the y-intercept is y equals 10, and I can confirm that by graphing. To do this one, I think I'm going to go ahead and just graph it, because why not? Not going to do any math here, just graph it. So I have, let's see, x plus 2, x minus 1, and x minus 5. Oh my goodness. Plus 2, minus 1, minus 5. Is my scale off? My scale's still weird. Zoom, 6. Yeah, that didn't look right. It's like, okay, cool. That's more what I was expecting. So I am seeing a few different relative extrema, but let me actually just increase my my y scale a little bit. So I'm going to go from -20 to +20. I think that'll do it. And then I can just kind of drag this over here. Good. So first of all, is it increasing from -3 to -1 or decreasing? So -1, -2, -3. So -3 is like here. -1 is here. So I will say increasing. Then it says how many relative extrema does it have? So it has a relative maximum there and a relative minimum here. So because it's going to keep going here and it's going to keep going here. So it has 2 relative extrema. There's a maximum, there's a minimum. Okay, onward. All right, so we've got this table and it's asking us a bunch of stuff. So I'm going to go to my calculator. I'm going to pause the video in a second and I'm just going to put all this in because you probably don't want to watch that happen again. I've already taken too long on this video key. It's hard to do these quickly, so I'll see you. All right, I'm back. I put everything in. So I did a few things just to make sure it worked because I didn't want to have to do this multiple times. I plugged all the numbers in. Then I have to go, if I'm finding a correlation coefficient, which is something I'm doing later, I want to turn my diagnostics on. So I went second, catalog, right down here by the 0 key. Alpha's already selected, so I can just go straight to a letter of the alphabet. So I hit the D right here, the D key. And then I'm scrolling down to diagnostics on to do a correlation coefficient, and I turn them on. Now it asks for a linear regression equation rounding to the nearest thousandths. So I'm going to go to stat, calc, linear regression, and I'm just going to grab this thing and move it over here so I can work with it. All right, so linear regression equation. So I have 11.9, so that's tenths, 9, that's 100th, and 3. There's a 1 after that, so I can just leave it as a 3. X, so I'll say y equals that, plus 186.88, and the 2 rounds up to a 3 because there's a 7 after it. Correlation coefficient to the nearest thousandth is this r right here, so that would be 0.978, and there's a 4 after that, so it stays as it is. I wrote that very sloppily. 0.978. R equals that. It tells me, well, first of all, it tells me 2 things. So there is a strong positive correlation. So the data, let's see, we'll say they're almost in a perfectly straight line. Okay. What is the slope? The slope is 11.993. This tells you that each additional gram of fat, so each time x increases by 1, y is increasing by 11.99. So we'll say each additional gram of fat adds 11.993. Really, I'll say adds about 12. All right, cool. Use your linear regression equation to predict the total calories for a sandwich with 10 grams of fat. So I can just plug 10 in for x. So let's see. 11.993 times 10 plus 186.883. It wants me to round to the nearest whole number. So 11.993 times 10 plus 186.883. It's about 307 calories. All right, and that is the Regents. I really hope you guys did well.